Okay, question 5. The question says we have a curve fx, and when you differentiate the curve, you get ax squared plus bx. A and b are both positive. Find in terms of a and b the non-zero value of x for which the curve has a stationary point. So curves have stationary points where the first derivative equals 0. That means that ax squared plus bx must equal 0. So when does that happen? Well, that happens when, let's just factorize this. So if we factorize, we need to solve this. So either x equals 0, but it does tell us in the question we're only interested in the non-zero value of x, so we can ignore that. And the other value will be when this equals 0, so when ax plus b equals 0, which means that x will be minus b over a. So that's where the stationary point occurs. But we now need to find the nature of the stationary point. So for that, we need to find the second derivative. F double dashed x is going to equal 2ax plus b. Just differentiating again. And we need to sub in when x equals minus b over a. So when we do that, the second derivative will equal 2a times by minus b over a plus b. Now these are going to cancel, and that's going to leave us with minus 2b plus b, and minus 2b plus b is just minus b. So we know in the question that a and b are both positive. That means that minus b is definitely going to be negative. So this is less than 0, which means it must be a maximum point when x equals minus b over a. In part 2, we know that the curve has a stationary point at the point minus 2, minus 3. In other words, where x equals minus 2, there will be a stationary point. So that means that f dash minus 2 is going to equal 0. And f dashed x is ax squared plus bx. So ax squared plus bx, we will substitute in minus 2 into there. So that will give us 4a minus 2b, and that's going to equal 0. You could probably divide everything by 2 here, so 2a minus b equals 0. We also know that the gradient of the curve at x equals 1 is plus 9. So that tells us that f dash 1 equals 9. So again, we're using ax squared plus bx for f dashed x, and if we substitute a 1 into there, that's going to give us a plus b, and we know that equals 9. So we have two simultaneous equations here, this one and this one. The quickest way to do this, I think, is to add these two together. If we add these two simultaneous equations, we'll get 3a. B's will cancel. 3a equals 9, so a equals 3. And using this equation here, b is going to equal 6. So we're still carrying on with part 2. So now we know that a equals 3, b equals 6. The equation of f dashed x is 3x squared plus 6x. The question asks us to find fx, so we're going to need to integrate this now. So fx equals the integral of this, which is going to be x cubed plus 6x squared over 2, which is 3x squared. Now don't forget your plus c here. Now, in order to work out what c is, what we can do is substitute in this coordinate. So if we call this y equals x cubed plus 3x squared plus c, we know that when x equals minus 2, y equals minus 3. So minus 3 will give us minus 2 cubed plus 3 minus 2 squared plus c. Minus 3 equals minus 8 plus 12 plus c. I think that's going to give us 5 minus 12, that's minus 7. So c is minus 7, and we can then substitute this back into here, and we'll get what fx equals. So fx is x cubed plus 3x squared minus 7.